There is a non-zero probability that at this very moment you might find yourself on the surface of Mars. And no, this is not science fiction. It's one of the consequences of the tunneling effect, a fascinating quantum phenomenon that allows particles sometimes to be found in the least expected places. Oh, really? You might say, and you'd be right. Your atoms remain where they should be, and you don't miss any, or at least you think so. This is because they are very small, extremely small. Assuming you weigh about 70 kilograms, you have 100,000 times more atoms than the number of stars in the entire observable universe, a number much larger than another already inconceivable number. So your atoms, being so many, have to be very, very small to fit in your body. That's why you don't notice the tickles caused by the tunneling effect. Quantum effects are mainly noticeable on smaller scales, where one of them, many atoms, becomes something very relevant. It's highly probable, for example, that an electron from your body has suddenly decided to go somewhere nearby, and this has been experimentally verified. For larger distances like Mars, the probability decreases. Specifically, there is a probability of 1 in 10 circumflex 18 that one of your electrons is currently on the red planet. Ridiculous, yes, but not zero. The point is that your body has so many electrons that sooner or later it will happen to you, and it has happened. That's why it's very easy to test this theory, because it's very easy to obtain electrons. They are so small and abundant that acquiring enough to have a sufficient sample for the tunneling effect to occur is not difficult, and this has been done several times in the laboratory. When firing a beam containing billions of electrons against an impenetrable barrier, the electrons are forced to bounce back. They bounce. A detector located on the side where the electron source is continues to detect electrons, but if you place a detector on the other side, which obviously shouldn't detect anything, it detects something. Occasionally, some of the billions of electrons, due to the tunneling effect, suddenly appear on the other side of the barrier. No, it's not that they could pass through it. They've appeared on the other side. If you roll a die enough times, you'll get a 6 times in a row, even though the probability is absurdly small. The same goes for electrons. If you have many together, sooner or later, one will appear somewhere you thought it was impossible to find. Less likely, but not impossible, is that one of them will go somewhere farther away, like the electron from your rear end that just went to Andromeda. For your entire body to appear on Mars, that is, for all your particles to undergo tunneling simultaneously and appear in the same place, it would take an enormous amount of time. Because it's rare for a single particle to do it, for all the particles in your body to do it at once, and in the same place is difficult. But the point is, it's not impossible. You might say this borders on the absurd, but I would reply that more improbable things have happened. Statistical oddities of enormous importance that allow us to be talking here today. After all, it's all a matter of time, of everything that is to come. We can't predict it with absolute certainty from what we've just seen, but we can make pretty good predictions. And this raises the following question for me. Can we always predict what will happen? How far do our most futuristic projections go? And more importantly, will things always be happening, or will we reach a point where there is simply an end? Does time or the universe have an expiration date? Before addressing the end of the universe and time, it might be more sensible to talk about our end, that of humanity and life. By the way, I warn you that in this video, you will have to make an effort to comprehend the magnitude of the timescales we are going to discuss. To achieve this, let's visualize 4 important events in the history of the cosmos, such as the Big Bang, the beginning of everything, or, isn't it? Shut up, Marty. That in the end. Sorry, the formation of the Earth, its end, which will probably die engulfed by the sun, and the death of life on this planet. Try to stay with this corner because it will serve you for what I was saying to understand the magnitude of the time scales. Personally, When I see this scheme, I am always curious about how long the Earth has existed, though it is so significant, so comparable with respect to the total time that the universe has existed, because a planet is insignificant in front of the cosmos, and yet here it is, occupying more than a third of the total time that the universe has existed, as if it had been in a hurry. Wait a moment, Marty, you said earlier. End of life on this planet? How can we know this? And why is it so close to us? Because life on this planet is running out of time. Humans have appeared at the end of its useful period for life, if we can call it that. In just 600 million years, the brightness of the sun will have increased so much that the weathering of rocks, that is, the chemical reactions that modify rocks, creating new minerals by reacting normally with rain, will increase. These chemical reactions involve carbon dioxide present in the atmosphere, which becomes part of the rocks in the form of minerals called carbonates. And this is good, if not in excess, since it prevents this gas from accumulating in the atmosphere. In geology, it is called the carbonate-silicate cycle. The thing is, in the next million years, there will be more light, there will be more energy available for chemical reactions, and especially more evaporation of the oceans. Now, there will be much more water in the atmosphere, that is, it will rain more and more carbon dioxide will be trapped. But things will get much worse. There will be less and less liquid water on the surface, so the tectonic plates will become rigid and stop flowing. They will stop. And this movement of plates is precisely the only way the planet has to renew the carbon dioxide trapped in rocks. By moving plates, rocks with gas end up going deep and melting into magma, thus releasing the gas, which returns to the atmosphere through volcanoes. But without plate tectonics, there are no volcanoes. There is no renewal of carbon dioxide, which was already starting to become scarce. And guess who needs this gas to survive? Plants. Plants die. And with them, all the animals that directly or indirectly need them to live. All animals, remaining living beings, and other processes consume the available oxygen in a few years, which is no longer renewed. All complex living beings die. In a billion years, this planet will be the largest known cemetery in the universe. By then, only in what were once vast oceans full of life, there will be small residual pools of hypersaline water almost boiling, which will harbor small, simple, extremophilic, unicellular microorganisms. It will be all that remains of what not long ago was a flourishing planet of life. But humans will not arrive alive on that day. Three things can happen. Either we will have evolved into another species of primate, although maybe we will no longer be mammals, but another biological class yet to appear, or we have joined with machines and artificial intelligence, becoming cyborgs, or most likely, we or our descendants will have become extinct. It seems that it is something normal that happens to complex life in this universe. Why isn't the cosmos full of signs of intelligent life? As we saw in another video, it is possible that the same nature that brought us to where we are will also end up being our sentence. But what will happen to those microorganisms that will survive in small pools? Could they be the beginning of a new era for life on Earth? Not at all. They will all die. Within 3,500,000,000 years, the increasing brightness of the sun and a powerful greenhouse effect will literally melt the rock surface. These bacteria would have to evolve greatly to survive. But it's not even like this, because within 7,500,000,000 years, the sun, which will be growing due to the natural cycle that stars have from its mass, will swallow our planet. A little snack for our star, which will mean the end of 12 billion years of history. Ironic as what gave us the energy to live for so long will be our last and most deadly enemy. But things will continue to happen. Whether or not humans have fulfilled the interstellar dream, traveling to other star systems, we are or not to live it, there will be other life forms in other corners of the cosmos that will continue to live, following the cycle of the universe. Think of our sun, for example. After eating Earth, it will continue to grow a little more until it collapses on itself, forming a very beautiful planetary nebula, spreading chemical elements that may someday be part of the brain of some intelligent living being. The history of the universe will continue. Here you can forget about the timescale scheme before, because things are going to get out of control. Trying to understand these timescales that follow is just as impossible as trying to understand the number of atoms in your body or the size of the observable universe. Simply put, our brains are not designed to imagine such amounts of time and sizes. Natural selection has prepared us to live in a small part of a planet, not in the entire space-time universe. New stars will be born for a long time, some of which will live much longer than ours. Red dwarfs